Bismillahir Rahmanir Rahim. Average and instantaneous angular displacement. To move further, first of all, we define the uniform circular motion. Uniform circular motion is the motion of an object traveling at a constant speed on circular path. For defining the average speed or average angular speed of a body moving in a circle, the average angular speed of rotating object is the ratio of the angular displacement to the time interval. For example, if a body rotates from point P1 to point P2 in some time interval delta t, initially it was at time t1 and it reaches to the point P2 at time t2, then the average angular speed will be delta theta over delta t. While the instantaneous angular speed is defined as a limit of the average speed as the time interval approaches to zero. Let me explain it in some elaborative way. You see that average speed is the ratio of total angle to the total time, but the concept is that average speed is just the ability how much fast that body is. If the speed or the ratio is more, then it means that the body is more fast. For example, if the body is having a speed of 5 degrees per second, then it doesn't mean that it has covered the angle of 5 degrees. It may have covered at an angle of 2.5 degrees, but in half second. It means that it has the ability to cover the distance of 5 degrees of our angular displacement of 5 degrees in full 1 second. Initially, it has covered from, for the sake of discussion, we are assuming that the body is at point P1 and in moving from point P1 to P2, body has covered 2.5 degrees in half second. If it continues to move for the full 1 second, it will cover a angle of 5 degrees. It means it has not covered 5 degrees in half second, but it has a speed or the ability to cover the distance of 5 degrees in 1 second. It means it is fast enough to cover the distance of 5 degrees in 1 second. So speed is not the angle or angular displacement, but instead it is the ability to cover the distance or displacement in 1 second. It is just ability or the fastness or how much fast is that body in circular motion. So speed doesn't represent the displacement only, that how much displacement is covered. Instead, it represents the fastness of the body. Similarly, in the case of instantaneous angular speed, it is the ability of a body at certain instant of time, that how much ability at that instant a body has to cover the angle. For example, if a body at point P is rotating in a circle, then what is the ability at this point P? This ability of covering the angle in 1 second is the instantaneous speed. It means during the circular motion at this instant while it passes through the point P, the ability at this instant to cover the distance or displacement, angular displacement in 1 second is known as instantaneous angular speed. So body can have different abilities or fastness at different instants. Then we can say that the body will have different instantaneous speeds. If the body is moving with uniform angular speed, then at every instant it will have the same ability or same instantaneous speed at every instant. The SI unit of the angular speed, that can be average angular speed or instantaneous angular speed or uniform angular speed, the SI unit for all these is a radian per second. Angular speed, if rotating in counterclockwise, it is taken as positive, and angular speed will be negative if body is rotating in clockwise direction. There is a right hand rule for establishing the direction of angular velocity, as angular velocity is a vector quantity. It has some magnitude and some direction. Magnitude of the angular velocity is actually the ratio of angular displacement to the time, or the numerical value calculated using this formula. This represents the magnitude of the angular velocity, while the direction of angular velocity is given by the right hand rule. For getting the direction of angular velocity, you have to grasp the axis of rotation of the body in your right hand in such a way that your fingers curl in the direction of rotation. For example, in this figure, if body is rotating in anti-clockwise direction, then thumb points in this direction, and the direction of thumb is actually the direction of angular velocity according to this rule. And similarly, if the direction is clockwise, then the thumb points in the opposite direction. So in future, you can define angular velocity is a vector quantity with a magnitude and direction. Magnitude will be given by the ratio of angular displacement to the time, while the direction will be given by the right hand rule. Thank you for watching the lecture. Please subscribe this channel for more informative lectures in all subjects, and please visit the website www.cancollege.com. Thank you.